just a little bit of introduction. I come from a background, I'm a physicist by training. My Ph.D. is in experimental quantum mechanics about 15 years ago from the University of Michigan. Taught college for about 10 years in the physics world, and then transitioned to be a card reader, to the thing that goes whoosh when the door closes, all of that. There's data all over the place. And having somebody who knows what to do with data tends to be a helpful thing for business. So I'm going to talk a little bit about what I think of as data science, and then we're just going to dive in here, and I'll show you an example of the way in which I think about data and the way I use Python to think about data. So because I'm an experimental physicist and I taught at a liberal arts college, for me, science means exploration. Science means curiosity. Science means building useful models that help us do useful things in the world. So the transition from that kind of science as a physicist to that kind of science with corporate data or business world data was pretty easy because the same ideas still apply. So hopefully I can model some of that today and talk about how to be curious about data and then how to use some of the awesome tools in Python to do that. Um, I'm going to use a Jupyter notebook. Are people familiar with Jupyter? Is this something people use? A couple of people. If you have not used Jupyter before, it is a Python kernel on the backside and an in-browser interactive experience on the front side. From a data scientist perspective, Jupyter is wonderful. It lets me play around with things without really knowing what I'm doing. And then when I finally get to the point where I have an idea of what this is going to do, then I'll just script it as Python script and run it like normal. So for the most part, I tend to use Jupyter for everything. Please connect with me on LinkedIn, and this is a GitHub repo. So you're welcome to go get it and play with it yourself. It's out there. So why a time series? So when a time series, what I mean is data that I have as my x-axis, I have time. And in this case, I'm gonna look monthly, but it could be seconds, it could be hours, it doesn't really matter what. And the vertical axis can be in just about anything I want. In some sense, as a physicist, we looked at position versus time. We didn't call them time series then, but that's what they were. And in the business world, time series tends to be very useful for things like sales over time, or demand over time, or inventory over time. And all of those things become very useful from a business perspective to be able to forecast, to be able to predict what's going to happen. So I tried to pick something that's pretty universal. Pretty much everybody in any business could use time series forecasting. This could be something that's useful. When I was a teenager, I worked at Kentucky Fried Chicken, and we did our own rudimentary time series forecasting. I don't know if you know, like backside of Kentucky Fried Chicken, the chicken gets cooked in batches. It doesn't get cooked like right when you order it. And so they have to have an estimate how much chicken they need so that it's cooked by the time customers get there. Well, how do you forecast that? How do you know how much you're going to produce? And so as a teenager, I didn't know anything at all about Python or any of the rest of this stuff. I don't think it existed. I won't tell you how many years ago. But the management had a tracking system where they kept track of how much such business is forecasting many billions of dollars of sales. Time series is useful across the spectrum. And then why Python? Because it's easy and because it's really straightforward to use. The libraries make it easy. The code makes it easy. It's like all across the board. Anybody can do this. I truly believe anybody can do this. All right, so getting started, I use the Anaconda Python distribution. It is more than just base Python. It has a whole bunch of packages already built in that they take care of those things for you. And so if you had just base Python on your system and you tried running the notebook, it's probably not going to run. So I'm assuming that you've got Anaconda because of all the libraries that I'm just assuming that you're there. And if you don't have Anaconda, if you have Anaconda but nothing else, then this first statement where I try importing pyramid ARIMA, if that doesn't work, it will install it for you, and then everything else should work. So I'm gonna dig and what I'm using them for. We'll see how that takes time wise. So pandas, anybody use pandas? All right, matplotlib is a great graphing. No, it's not great. Matplotlib is a graphing library for Python. It's pretty much as good as you get, but it's awful. I'm just coming from where it's like developing publication quality scientific figures was my life for 15 years, and then having to do that in Matplotlib was painful. So there's a handful of other utilities here: JSON requests, get past date time warnings, relative delta. And then the meat of the good stuff is from the StatsModels library and from this pyramid ARIMA library. And we're going to use those two, the seasonal decompose and auto ARIMA. Those are really where the guts of understanding what the data is doing. And when you execute the cell, and so you run the code, it remembers that you had this function. So it's nice. It also remembers everything, every variable you define, it keeps in memory so that you can define it in one cell and use it later on. It's very nice. It's very interactive that way. All this does is lets me print off things, and so instead of a big long list, I put it in columns so you can look at it a little easier. All right, so I'm going to use a publicly available data set. This is the Iowa liquor sales data. The state of Iowa, about 9 years ago, started recording every sale of a class of liquor to a class 3 liquor license, or sorry, class E liquor license holder. So these tend to be liquor stores, tend to be casinos, they tend to be restaurants. So when somebody sells the restaurant a bottle of Jack Daniels, that gets recorded as a public sale. Who bought it, where they bought it, when they bought it, how much they bought, how much they paid for it. It's all public data from about 2012 forward. So I guess it's 7 years ago now. Because it's a publicly available API, I just need to know how to get that data. All right, and I'm going to use the Python requests library. And there's some documentation of like how to format your query, and I need a URL that shows me where to go. And then I've got some query details that just mean I spent some time reading through the documentation. But I'm going to take all of the sales for a county, and I'm going to sum them all up for every day. All of that up in a great big bucket. I send the request via the request library, and then I'm going to print out the output. And I get stuff that looks like this. And I see that I've got things that look like dates. That's good. I've got things that look like dollars and liters. Those are good, except they're looking like they're strings, so I'm gonna have to deal with that. And counties. That's good. That's what I asked for. So that works. If I change some of the parameters, instead of an offset of 1500, an offset of 10, I get hopefully 10 different results. And because I'm doing live demos, it's always the risk that this isn't going to work. So hopefully my query goes out and it queries the database and it will come back in a finite amount of time. Well, that ponders itself. I wrote a little helper function that does basically that. I've got my URL and my query, and I've got a parameter now that I'm passing into my function that is the offset. So I can only ask for 50,000 values at once. And so if there are more than that, I have to ask again, but this time say, give me from 50,001 on. And if there are more than 100,000, I have to ask again. And so I created this little offset. Hey, it returned values. So with that little offset, then I can run it once and get a set of data. And whoops, I got to run the cell. There we go. And I got 50,000 queries, which means that, and there should be less than 50,000, which means that I didn't max out, which means I've got everything. And I could write a little for loop that would let me step through those things and make sure that I get all the data back, if it works. Okay, so from there, the data is in this JSON format, where it comes back where I have the county and then the name, and I have the value and then the name. And the pandas data frame is a very, very useful tool for taking all that data and turning it into something that looks like an Excel spreadsheet. And that Excel spreadsheet makes it easy for me to do column-wise operations where I can take a whole column and do something to it. So I don't want to leave the data in JSON format. I want to put it in pandas so that it becomes really, really easy. And I'll show you some of the really cool things that you can do with pandas data frames. So there's a nice function, and again, read docs. In pandas, that is the .io.json.json normalize that takes whatever JSON you've got and squishes it into a pandas data frame. And then I do that for both my data sets that I got. And then that final one, that df.head says, print out the top 5 rows. So it gives me a chance to take a look and see what do I've got there. So I've got county, I've got date, I've got my 2 columns that look like dollars and liters. And JSON normalize was smart enough that it's actually turned some of those numbers into numbers for me and took care of that in the background. All right, so that's what I'm going to work with. So just as sort of a note to self, I don't want to do this every time I want the data. So there's a 2 CSV that will save it on my local hard drive. And then when I want to do it again, I just run the read CSV function and it pulls it back in. So that way I don't have to call the API every time I want to go back to this data. It means that I don't get the latest stuff because I only got the data from the last time I called, but for just the exploration, that works. Is its own little NumPy array. So did my data come in a way that makes sense to me? So I'm using D types, and that tells me each column, if I want to do things with dates, I need a date. So Python thinks it's a date and not just a string. And you can see the date column says it's an object, which is not a date. It thinks it's a string. Object means I don't really know what it is, so I'm just going to call it an object. So before I do anything else, I'm going to convert that to a date. Fortunately, with most things, there's a library that does that. There's a function call that does that. One of the nice things about using Python and open source libraries like this is that I'm not the first person to have this issue. And somebody else has had it and written a library and gotten it published to the overall package. And so that's just a little nicer. It just shows up as a formatted year, month, day, date. All right, so now that we have some data, there's because when I sum up by month, that would make March look weird. So I'm going to end the end of February. So I'm just going to cut off the end of February. All right, so what do I have in counties? I have looked at this data before. I'm going to do 3. And remember that whoever was putting this data in the state of Iowa's database did a bad job of it. So in my list of counties, you can see I have Adams County in capital letters, and I have Adams County in lowercase letters. I have Buena Vista in capital letters, and I have Buena Vista in lowercase letters. So it's a mess. And that one of the sad realities of a data scientist is that 80% of my time is spent cleaning messes like this. This is the life, right? It would be nice if it weren't that way, but it's a mess. Including the classic El Paso County, Iowa, which, if you're not familiar, doesn't exist. Like, there is no El Paso County, Iowa. Okay, so I'm gonna clean it up. I'm gonna make everything uppercase. So I'll make the whole column uppercase, case, last letters, or whatever. And then I'll spend a moment here talking through some of the power of using pandas. What I've got in that line of code says, df is my data frame. It's got all my data in it. .loc says, look for locations where. What's in the square bracket says, all right, I'm going to look for where the county column, df county, is not equal to El Paso. And so by assigning that back to the data frame, it says, everywhere where the county is not El Paso, keep that. So it's a nice way of cutting out the data that I don't want in the end. And one little line of code, now I don't have to worry about El Paso. It should go away. And if I did this right, I should have a nice, much cleaner sense of, I'm going to do new columns. All right, so my counties look better. Yay, I no longer have a mess on the county piece. Okay, so the last piece is that looking back at my date column, I have things like February 14th and December 26th and August 22nd. I don't want to do this on months. And so I need to get rid of the day part of the date. So all of them. So what I'm going to do is create a new column here. I'm going to call the new column month. So this says create a new column in my data frame called month. And what I'm going to do is I'm going to take the date column and I'm going to apply a little lambda function. It's a little inline function that lets you do custom things. And that little lambda function says, take whatever was there, convert it to a string where I'm using the year and the month, but 01 for the day. So I'm just going to ignore what the day was and call it 01. And then the next line is convert that from a string back into a real date time. So now I should have, when I do df head, I should have a new column that I didn't have before, that month column, that has now the first of the month for all of them. So now I can take that data and I can add up all of the county for all the days of the month, and it'll all add up nicely into that one bundle, or into that one group. Okay, so this is the part where I really get excited because now I can start to take a look and see what I've got. Maybe 25 years ago, 30 years ago, the way people would look at data like this is that they would have big reams of printed out pages and they would look at numbers. Fortunately, we don't have to do that. When we have 65,000 data rows, we don't have to look at them one by one. We can graph them. We can plot them. So here's what I'm going to do. The first thing I'm going to do is I'm going to group by the month. So I'm going to take, I don't care what county you were in, I'm going to add up the entire state, all of the counties, each month. I'm going to sum all the data. So that last piece is .sum. So I'm going to group by month, I'm going to add it all up, and then I'm going to create a new data frame I'm calling state data. And then the second thing I'm going to do is I'm going to say, all right, just give me just the sales of liquor in liters. So this is not dollars. I tend to like liters better because it gives me a sense of real consumption, like what are people actually drinking, not how much did they spend drinking. Dot plot. So I'm going to show. And because I had done the group by, month is going to be the x-axis. That will be the index of the pandas data frame. And then I'll give it a nice label because it's important to label your axes and show what I've got for the plot. So I apologize for the slightly small axes labels here. It's a little smaller than what I'd like, but all right, it's what it is. So the x-axis is month from 2012 to 2019. This is February 2019, so last month. And the vertical axis is how many liters, which are averaging, how many zeros are there on here? 1.6 million liters of alcohol per month that the people in the state of Iowa are purchasing. Right? That I don't have any sense because we don't have data for any of their states that high or low. But that's 1.6 million liters of alcohol. This is hard liquor. This isn't beer and wine. This is the good stuff. So what does it mean? All right, I have data now. I have a plot. What do I see anything? Does any of that look at all like there's any patterns or anything there that makes any sense at all? Well, except for by month. Yeah. So if I look at the left-hand side, there are spikes there. And I find this actually really curious. Those spikes are 3 months before the end of the year. What happens in Iowa in the month of October? Actually, it's probably September, October, November-ish. So I think that's football season. I think there's definitely a New Year's spike in the month of December. There's a holiday spike in there. When I dug a little bit more, there's actually a spike in March for March Madness. But because Iowa's not a huge basketball state, it wasn't as big of a deal as the football in the fall. Okay, so it'd be really nice if I could separate out all of what's going on. So I'm going to take a look at the StatsModels library. In order to understand what's going on with the StatsModel library, I'm going to create a little simulated data set first. And that data set is going to look like this, where I have waviness and I have a trend. And StatsModels is really awesome. I use the seasonal decompose, and it breaks it up into 3 pieces. It breaks it up into leftover in my test data. So let's do the same thing with Iowa with the statewide data. And sure enough, we get a trend. Alcohol consumption on average is increasing in the state of Iowa over the last 15 years, or the last 9 years, I guess. There is a repeatable trend piece, and that's where you can clearly see the October and December, and you can see sort of the springtime hump, and there's leftover pieces. All right, so now that I've got this, I am ready to forecast. I have everything I need. Okay, so let's do this. As a data scientist, I want to save a little bit of my data off to the side so that I know whether or not my forecast worked. So what I'm going to do is I'm going to cut my data from June 2017 on, and I'm not going to forecast using it. I'm just going to leave it aside. I will forecast using everything up to that point, and then I'll use that forecast to predict forward and see how well do my predictions match what actually happened. And to get a comparison, I'm going to do a really simple forecast, and this is what we did at Kentucky Fried Chicken so many years ago. What did we sell last year? That is my baseline, because if what we sold last year is a better predictor of what we're doing this year, then I don't need to use Python to do it. I could just look at last year's numbers. All right, so that's my baseline. All right, so let's take a look. What does the baseline look like? You can sort of see it, right? There's little green X's. That's last year's data. All right, it basically is a grid search algorithm that tries a whole bunch of possibilities and finds the best one and tells you that's the best I can do. All right, how good did it do? Well, We can look at some of the details of the model, but it doesn't matter. All right, so this is how well it did. Wow. This is the disadvantage of picking colors on a screen and projecting them. You can sort of see it, right? There are now sort of the shaded area, and just like a hurricane forecast, all forecasts have bounds. How well do we think we know what's going to happen in the future? So think of this as the forecast of the hurricane. I'm okay. I'm confident. But see what happens to the forecast as I get further and further out? My forecast gets worse and worse. Like I know less and less of what's going to happen to the point where it's like almost anything can happen. But it's not really what I wanted. What I've done is predict 19 months from now. But as a business, it would be much more useful to predict next month from now. And then next month, I predict next month from now. Then the month after that, I do the same thing. So what I want is something that looks closer like this, where the blue dots are what I use to make the predictions, the red dot is where I'm predicting, and the gray dots are things that I ignore for now. So now I need a for loop, and I'm going to iterate through each time and increment 1 month, predict out next month, and then record that prediction, and then repeat, and then just keep doing this over and over again. I learned early on that if I didn't do this kind of little output, it would sit there and do nothing, and I wonder like how far along am I? Like how much longer before it's done? If you haven't played around with the TQDM library, it will do this in really nice progress bars for you. It's very nice. Okay, let's look. Uh-oh. I missed something somewhere. Oh, that one. Too many indices for array. Oh, great. Now I've really broken it. That it let you explore and play. The bad thing about Jupyter Notebooks is that if you reassign the variable somewhere, it reassigns it in memory. And so everything further on down the line thinks that you've reassigned it even if you haven't. So somewhere along the line, I messed it up. All right, so I'm going to burn through. All right, so that one. All right, there we go. All right, I got to rerun the forecast for the daily, and then we'll be done. Yeah, thanks. That is the downside, because you can get yourself into little circles and loops where you make adjustments and you make changes to your code, and later it doesn't work because you've gone back upwards and done things differently, and then you've got a mess. And I would be lying if I said I hadn't done that before, because I have. Wow, I messed something up. Yeah, okay. That one work? I'm gonna guess. There we go. All right, that'll work. Bugging the code, right? So this is the forecast now, where I have gone through and each month predicted the next month. And compared to before, where I had the forecast bounds that grew really, really big, I'm doing much better. And the forecast looks like it's pretty reasonable. There are ways of doing really tight measures, like how well is my forecast working, how good am I doing. I'm not going to worry about those right now. What I really wanted to get was a qualitative sense of how well the forecast is working. One of the things I notice with the forecast is the size of my bars, and I can actually measure the size of those bars. They're almost 500,000 liters, plus or minus. That's not a small number. That's a pretty big number. It's about 30%. So my forecast is not better than 30. The data is noisy. When we go back up to that decomposition where I showed the linear trend and the repeatable part. So the trend of how things are growing, the repeatable part, and then 20,000 liters per month. And so I'm not going to be able to forecast noise. You can't do it. It's not possible. So the fact that the forecast is only good to about that, I'm doing okay. I really don't have anything better that I can do. So the GitHub the notebook and the repo goes through, and we dive into month by month and see if there's some counties, or county by county, to see if there's counties that have more interesting or less interesting pieces. I actually pulled data from the US Census to look at per capita consumption of liquor in Iowa, because I got curious. And it turns out that there's a couple of counties whose per capita consumption is way above the rest of the state. They've got reservoirs. The per capita consumption in the summertime goes way up because people come in to visit the reservoir. And it turns out like boating and drinking is a thing. So to the GitHub repo. And it could be general data science. It could be specific to time series forecasting. Or if you really want to talk about the wave function collapse of quantum mechanics, I'm willing to talk about that too. Just probably not public.
I don't even know what that last thing means. Oh, let me bring you the microphone. That way it's in the recording.
If you were looking at a problem like this, would you attempt any other forecasting methods other than ARIMA? Like
Your fit, right? It's like pretty straightforward and pretty easy. There are neural networks. Because looking at this first and seeing that there's noise in the data to begin with, ARIMA is not going to do any better than that. Noise has components that are more sophisticated than what an ARIMA model can look at, in which case I might win. It might be that the noise is fundamental because of the whims of humanity, and I can't. But this would be my first place to start, and then certainly poke in my nose into other places. Part of it will depend on the business need. If the business says, this is good enough, I'm done, right? And it took me a couple of lines of code.
Talking about the noise there in the graph, the third component, it's you mentioned it's just not possible to eliminate it. So when making the forecast, you've got to include it in the process to calculate the forecast.
So I'm including all of them together when I make the forecast because ARIMA can pull out the linear trends and it can pull out the patterns. And what it gives you left over is just the residual part of the output of the forecast. So the size of the shaded area, that is a reflection on how much noise I have.
Sure. So when you ran this last one, you did it on a daily, is that correct?
I looked at it by county. I've played around with the daily, but it gets really granular and hard to interpret what's happening. One of the things I tried daily-wise, it's actually not in this repo, but if you play around in my GitHub site, I have another repo where I dug a little deeper. I asked questions like, does weather impact the sale of liquor? And I can do that day by day. I can look at things like, does the number of tweets on the Iowa State University's football site impact the amount of liquor sales? There's a positive correlation there. So yeah, there's
Specifically suited for time series forecasting? Does it automatically take into account day of the week and that kind of stuff?
No, it doesn't. So inside the ARIMA, when I did this, there's a parameter right there. So seasonal equals true and M equals 12. You have to tell it what the period of the repeatable part is that you think is going to happen. There are other ARIMA tools that will find some of those things for you, but it also doesn't handle multi-periodicity very well. And so that's where I would really dig into multiple other tools to see what else I could find.
Got two questions. One would be, would the impact be on maybe recession-wise? Because you're looking at right at the time where it was pretty bad.
2008. That would be really awesome if we had pre and post 2008, so we actually could see the recession impact on sales. The overall trend looks like it has a definite dip. Oh, gee, that's the election, the fall of 2016. That's interesting. Apparently, the state of Iowa didn't need to drink.
Getting into Python, do you have any suggestions on best methods or where to get more information?
Yeah, my entry into Python aside from the fact that my first entry into Python was randomizing lists of students in my class to form them into groups. That was literally the first Python code I wrote was to do that. This stuff, there are some really nice tutorials on how to use Jupyter and how to get started. I find Jupyter really straightforward. I don't know if is it okay to say other places out there that do Python tutorials. DataCamp is pretty good at helping you step nicely into Python. We actually tend to use it at Allegion when we're helping people learn how to code, to go from nothing to something. And then from there, we can launch beyond that. There are other tools out there like that actually have in-browser, how do you write a line of code? How do you get started? Even the day of code kinds of activities, there are often Python versions of those. So I gave my kids the coding game Python exercises because my 16-year-old son hates semicolons, and so coding in most of the other languages is like, ah. I showed him Python. He's like, wow, this is great. Like, so that kind of thing. I think those are easy ways to step in, and actually have a little bit more fun doing it as opposed to feeling like you have to do one thing.
That's awesome. I like the aversion to semicolons as well.
So I had a question. When you did the auto ARIMA, is it then optimizing the model that you're going to get based on AIC or BIC? You can choose.
That's what it does.
So that you use that model.
There's a set of time series forecasting tools R, which is a cousin to Python. I don't know. You see the cousin to Python. It's slightly different than Python, and those time forecasting tools have been built out to a huge degree. And so somebody tried to take some of those and port them over to Python, and this is as close as they could get with it. And it's not exactly as nice as what you can do in R, but it gets you pretty close to being able to use stuff. And they use the scikit-learn terminology and methodology so that you run it and then you dot predict like you do with a lot of other scikit-learn things.
And then a comment. So it didn't make as much sense for the case you did, but one of the nice tools in Paint.
Some fantastic libraries, both for dealing with time and dealing with slicing and dealing with all parts and pieces. I live and breathe by pandas. Yeah.
That's awesome. Any more questions from Martin? Well, let's give Martin a big round of
Great.
applause. Thank
Thanks,
you for
everyone.
coming out.